complex numbers, where we are going to learn the question on de Moivre's, how to apply mathematical induction in solving complex numbers, and we are going to also apply binomial theorem in mathematical induction. Okay, so let me. This is in HL paper 2, HL paper 1, May June 2016. Paper 1. Uh, this will be in the section B of the question. Okay, so let us solve the first part of the question. Let me tell you what all concepts we have to apply here. I'll tell you some basic concepts which we need to know. So whenever you have z equals to cos theta plus I sine theta, now according to de Moivre theorem, z to the power n will become cos theta plus I sine theta whole thing to the power n. So this will become cos of n theta plus I sine n theta. So which you can also write it as cis of n theta, z to the power n. This is method by de Moivre's theorem. And we need to know what is mathematical induction. In mathematical induction, first step you have to show m or k is equal to 1. Function follows k is equal to 1, then k is equal to n, then k plus 1 is equal to n. So these three steps, if it follows, then you can say that mathematical induction is proved. Now let us solve the first part of the question. I'll paste the first part of the question. Now de Moivre's theorem, find the value of cos pi by 3 plus I sine pi by 3. So what happens? The power 3 will come and stick next to it. So cos of 3 times pi by 3 plus I sine 3 times pi by 3. So now this 3 and this 3 can be cancelled, cancel it. So this 3 and this 3 can be cancelled, cancel it. So you have cos of pi plus I sine. Now the value of cos pi is minus 1, is 0, so 0 times minus 1, I is 0. So the answer for this is minus 1. Next, I'll take the second part of the question. Now, use mathematical induction to prove this. So first, what did I say? First you have to take n is equal to 1 to prove this. So let us take that. So cos theta plus I sine, sorry, I sine theta whole to the power 1, is it equal to cos of 1 theta minus I sine 1 theta. So this is nothing but cos theta minus I sine theta, which is our original value, cos theta minus I sine theta. So your LHS is equal to RHS, right hand side are equal. So this function is proved. You have to take n equals to, you have to assume n is equal to k is true. This is second step. This is your step 1 and this is your step 2. N is equal to k is true. So we'll put cos theta minus I sine theta whole thing to the power k, whole thing to the power k is equal to cos k times theta minus I sine k times theta. Now in the next step you have to prove that it is true for n is equal to k plus 1. We have to show that it is true for this. So let us remember this. I'll call this as an operation star. Next we'll substitute for this and see. So cos minus I sine theta whole thing to the power k plus 1, to show it as cos of k plus 1 sine k plus 1. We have to prove this. Okay, we have to prove. This is what we have to prove. So let us consider the LHS. Cos theta minus I sine theta whole thing to the power k 1. Instead of plus 1, can I do this as theta minus I sine theta whole thing to the power 1? K plus 1 is nothing but k here and plus power 1 here. This thing from the star operation, we know that cos theta minus I sine theta to the power k is cos k minus I sine k. So can we write it like this? So cos k theta sine k theta whole thing multiplied by cos theta minus I sine theta. Okay, now we have applied this first, whatever we have found here, that we have applied here. Now normal algebraic multiplication, this will multiply this as well as to the next one, then this will multiply to this as well as to this. So we'll do that. So cos k into cos theta, k theta multiplied by cos theta, then cos minus cos k theta into I sine theta, then we'll multiply this with this and both the terms, I sine k theta into cos theta. Next term is minus into minus plus, I into I is I square sine k theta into sine theta. Okay, now this and this term do not have I because I square term is positive, so these two are real parts. So cos k theta into cos theta minus sine k theta into sine theta. Then next these two terms take out, I'll take out common, cos k theta into sine k theta, sine just theta, sine theta, plus I is taken out common, k theta into cos theta. Now from these two terms, from real part, from these two terms, do we remember this formula like theta sine of plus b is equal to sine a cos b plus cos a sine b. Same way, cos of a plus b cos a cos b sine a sine b. This is a formula which is there in the booklet, formula booklet. You can use your formula booklet. Now can we apply this formula to the first part? So we end up getting cos of k theta plus theta, and the same thing here, minus I sine k theta plus theta. So can we call it as cos of k plus 1 theta minus I sine 1 theta? That is what we are supposed to find here. Yes, I forgot to mention theta here. Yes, this is, we have proved the LHS is equal to RHS. Go to the next part of the question. Now find an expression for z to the power n and z star to the power n. We have to remember something. Okay. Now we have to remember something like z to the power n, whole thing is z to the power conjugate whole thing to the power n. So this we need to remember before solving this one. Okay, now z is nothing but cos theta plus I sin theta. So cos theta plus I sin theta whole thing to the power n plus z star. What is z star? Z star is nothing but the conjugate. Conjugate of this is cos theta minus I sin theta whole thing to the power n. Okay, so according to the just now we have proved the theorem. So this will be cos n theta plus I sin n theta plus cos n theta minus I sin n theta. Now these two terms, take it as 2 times theta. Now these two terms are positive, same terms, negative and positive, so they get cancelled out. So the answer for this is cos n theta. Now next part says show that z times z star is equal to 1. So what does it mean? So cos theta plus I sin theta multiplied by the conjugate of it, cos theta minus I sin theta. You have to show, you have to multiply and show that it becomes 1. So first we'll multiply cos theta into cos theta. So cos square theta, then cos theta into this is minus I sin theta times cos theta. Then this will multiply with this plus I sin theta into cos theta. Then this will multiply with this. So minus I square theta. Now these two terms are same and negative and positive, they get cancelled out. So we are left with cos square theta minus this plus sine square theta. Now this is again equal to 1. Next part. Now write the binomial expansion of z plus conjugate of z to the power 3. Okay. So first let's just write the conjugate of this. Z a plus b whole cube is a cube plus 3ab square plus 3a square b cube. Okay, so that's what we'll write now. Z plus z star conjugate of z whole cube is z cube plus 3z into z square plus 3z into plus z conjugate the whole cube. Okay, now we'll club these two. This is z cube. Now these two will club. So z cube plus the whole cube plus 3 times into z bracket. For this it is z star. For this it is z. Okay, so this part is 1. Okay, so this part is 2 times. Just now we had proved that up. Cos n theta. So 2 cos 3 theta plus 3 into 2 cos 2 cos 3 theta plus cos theta. Then now cos 3 theta is equal, this is what we have to prove. Now let's consider the LHS part of it. So cos, so this z plus z star is nothing but 2 cos theta the whole cube. Fine. So this answer is 2 cos 3 theta plus 6 cos theta. 2 to the power 3 into cos cube theta. You have 2 cos 3 theta plus 6 cos theta. Fine. Now this is nothing but 8. So you have cos cube theta equals to 2 cos 3 theta cos theta. Now if you take this on the other side, you have cos cube theta minus 6 cos theta, which is your 2 cos 3 theta. Take out 2 and divide throughout. So you end up getting 4 cos cube theta minus 3 cos theta. This is equal to your cos 3 theta. This is what we are supposed to prove. End of this question. Yes, this is what we have to prove. I think this is the end of the question. We have one more part of this. Now, hence, prove this. Now, use the information, write it here. So, 4 cos cube theta, this term and this term will club, cos theta minus 2 cos square theta equal to 0. Okay, solve for this theta. Now, this is nothing but your cos 3 theta minus 2 cos square theta plus 1 equal to 0. Now keep it as it is, cos 3 theta. Now this you can write it as, you should know that cos 2 theta is equal to theta minus 1. Now this is the same term, but one is negative into the other sign. Okay, so if you take minus sign out, 2 cos square theta 0. So this is cos 3 theta minus cos 2 theta equal to 0, or you can write it as cos 3 theta is equal to cos 2 theta. Now, what is the possible values of theta? So theta can be 0, or 3 theta can be 2 pi minus 2 theta, which you get it as 5 theta is equal to 2 pi, or theta is equal to 2 pi divided by 2, or another possibility is 3 theta is equal to 4 pi. So 5 pi theta is equal to 4 pi. So theta is equal to 4 pi divided by 5. So these are the three possible answers. I think this is the end of the question. Yes.